back in lecture 6.1, this was example, that's what I was just looking at. It was example 3. Okay, so in lecture 6.1, example 3, we found the voltage and the current for this graph. So today we're going to use that information to answer the questions about the power. So we already know the following information because we did this problem before. We know that VRMS is 11.31 with an angle of 0 degrees. And we know that IRMS is 0.248 with an angle of 28.8 degrees. And actually the current lags the voltage, so that's going to be negative. All right. How can I find the average power, the reactive power, the complex power, and the power factor? You're exactly right. That will do it. But a quicker way is just to go VRMS, IRMS conjugate, and the rectangular form gives me P and Q, and the polar form gives me the apparent power and the power factor angle. So I want you guys to find the complex power. No, the 1/2 is when you do not have RMS. That's why we changed it to RMS. So the same formula in terms of magnitude would be VM IM conjugate over 2. Okay? Find the complex power in polar form and rectangular form. I have 2.45 plus J 1.35 volt amperes. Did anyone get that? Okay. In polar form, I have 2.8 with an angle of 28.8 degrees. Did anyone get it in that form? So that gives me the answer to the first 4 values. The real power at 0 minus -8 becomes positive. Theta V minus theta I. V is a 0, so 0 minus a negative number becomes positive. All right, so the real power is, oh, sorry, I'm off the screen. So the real power is 2.45 watts. The reactive power is 1.35 bar. The apparent power is the magnitude of the complex power. So that's 2.8 volt amperes. And then I can write the complex power in either form right here. So it'd be 2.8 with an angle of 28.8 degrees in volt amperes is fine. I'll just put that there. And the power factor is the cosine of 28.8 degrees. What is the power factor? The power factor is the cosine of 28.8 degrees. Lagging or leading? Okay, now, last thing is Thevenin impedance. It's just V, Z equals V over I. No conjugates, just V over I. Z equals V over I. That's 11.31 with an angle of 0 degrees over 0.248 with an angle of -28.8 degrees. What is the impedance? Voltage over current. You could give it in polar form, but it's actually more useful in rectangular form because then you can model it as a resistor in something. So I can either write it as 45.7 with an angle of 28.8 degrees, or I can write it as 40 plus J 22 ohms. Did anyone get 40 plus J 22 ohms? Okay, so that means I can now write this as a resistor that is 40 ohms in series with what? You got two choices. Is it an inductor, Ryan, or a capacitor? It's an inductor because it's positive. I knew that because of the lagging power factor. So it's J 22 ohms. 40 ohms in series with J 22 ohms. On page 5, example 4, it says for the following circuit, I want to know the total apparent power supplied by the circuit and the power factor of the circuit. We're assuming RMS values. So I could go through and find the values for all those elements, but since I'm looking at the total power supplied, it would be easier just to simplify the circuit and get the information like that. So I want you to simplify the circuit down to one voltage source and one impedance. Simplify that circuit down to one voltage source and one impedance. Please do that now. Check your answer with your neighbors. What is the impedance seen by the voltage source? Okay. So the formula that you could use to do this would be 10 in parallel with negative J40 plus 50. That result in parallel with J30. And that result in series with 20. What is the impedance? I didn't get that, Alfred. Keep working. 32.5 plus J 24.2 ohms. Anybody else get that? 32.5 plus J 24.2 ohms. So now, since I want to use S equals VI conjugate to solve for the apparent power and the complex power, I need to find my current. So my current is going to be V over ZQ, or 120 with an angle of 30 degrees over 32.5 plus J 24.2. I need to find my current, which is voltage over impedance. So I'm going to have 120 with an angle of 30 degrees over 32.5 plus J 24.2. So I got 2.96 with an angle of negative 7 degrees. 2.96 with an angle of negative 7 degrees. So I can get the power factor now. The power factor is just the cosine of theta V minus theta I, cosine of 37 degrees. So the power factor is the cosine of theta V minus theta I. Since I have the voltage and I have the current now, the power factor is the cosine of 37 degrees, or 0.8 lagging. How are we doing so far? Okay. So now I'm going to find my complex power, which is going to be VI conjugate. So that's going to be 120 with an angle of 30 degrees times 2.96 with an angle of 7 degrees. 120 with an angle of 30 degrees times 2.96 with an angle of 7 degrees. I want to write my answer in polar form because that'll give me the apparent power. 355 with an angle of 37, okay? So that is your complex power. And your apparent power is just 355 volt amperes because it's the magnitude of S. Okay. Last thing we're going to do is I want you to find P and Q for the circuit. Find P and Q for the source. And that's where we'll stop today. Find the average power P and find the reactive power Q. And we'll start on lecture 8.1 on Thursday. Either I'll be here to give it to you, or I'll give it to you on Teams, or it might even be a video, who knows? We'll figure it out. Last thing we're going to do today is find the average power P and find the reactive power Q. How can you find P and how can you find Q? How do we find P and how do we find Q?